The myth, the legend, and the Doge master, Elon Musk. During the recent crypto craze, his tweets played a huge role in pumping up coins or dumping them down. I'm not an expert about reading the market, however, just look at this one for example. He tweeted at there, then a massive pump began. In fact, it almost doubled the price of the Dogecoin, which is crazy. And from that reason, I wondered that if there is a way to estimate or predict future tweets from him, particularly the ones that are related to cryptocurrencies. So from that, I've created the Elon Crypto Tweet Predictor. First, I show you how I did it, then we see it in action. So, hit the like button and let's get started. So, first things first. To make predictions or to do basically anything, we obviously need data. Lots and lots of data. Because the more we have, the better our prediction gets. However, we know that there aren't millions of crypto-related tweets from Elon. So, to find as much data as possible, I've scrolled through his whole timeline until the Twitter decides to show no more. But before doing that, I've created a CSV file, which has two columns. The first one is the date, and the second one is the tweets. The dates column contains the dates that he sent tweets about crypto, and the tweets column corresponds to how many cryptocurrency-related tweets that he sent on a given date. It is actually quite simple. However, entering the data manually by scrolling through his timeline took a decent amount of time. But in the end, this is the file that we got. I know it ain't much, but data is data. Now we come to the most important part, prediction. At first glance, it may seem easy thing to do, but it is actually not. After a quite bit of research, I have figured out that one does not simply predict. And there are few reasons to that. First one is that when it comes to data science, machine learning or predictive algorithms, I'm a complete potato. See, the thing we try to accomplish is known as the time series prediction or forecast. Basically, we give the known data and ask computer, hey computer, will Elon tweet crypto on let's say 10th of March, and it will return us the result. There are few algorithms used to achieve that, such as LSTM and ARIMA. LSTM stands for Long Short-Term Memory and ARIMA stands for Autoregressive Integrated Moving Average. Well, that's a mouthful. Anyway, I try to understand them and read through some papers. And to be honest, I do understand few parts thanks to my previous trading and computer science knowledge. However, there are still parts that I have absolutely no idea about, which is a major roadblock. And to add on top of that, even if I understand it properly, implementing it is a whole another thing. Using APIs like Keras or TensorFlow is generally oversimplified. It is not very simple thing to do, especially if you don't have decent understanding. At that point, I lose hope and almost called a quit. But then I decided to keep searching anyway to see if I may find something interesting. And lo and behold, I found it. The Facebook Profit. By the definition, it says,
Profit is a forecasting procedure implemented in R and Python. It is fast and provides completely automated forecasts that can be tuned by hand by data scientists and analysts.
And just by this description, we understand that it is perfect for my use case. It provides simple usage, but it can be tweaked a lot. But enough talking. Now let's look at the code. Now, as you can see, this is the code that I've used to process data, train the model, and make predictions. I've based this on a tutorial I found on YouTube and the documentation of the Profit. You can find them and all of the resources I have used in this project in the description down below. Anyway, back to code. At first, we have imported the necessary modules. Then, we begin the data read and process. We read our CSV file, make a duplicate, and change its columns to Y and DS. DS stands for date stamp and Y stands for numeric value, which is in this case the amounts of tweets in a day. Then, we train our model by just using these two lines. There we can change sum of values to change uncertainty and so on. However, I won't be going into the details. Moving on, we are now ready to forecast. To make future prediction, we obviously need a future data frame. We can set it by using this line, and there we can give the period and frequency. In our case, the frequency will be daily and our period is 100 days. Now we can make a prediction and plot the outcome by using these lines. At that point, we are ready to give it a shot. So, when I run the program, we should get two charts. And there we have it. As you can see in the figure 1, we got the overall view of the prediction. The black dots correspond to the data we have given, The dark solid blue line corresponds to the expected values, and finally the light blue area is the possible range of these expected values. In the figure 2, we got more information such as trend, weekly and daily stats. So looking at them, we can say that we see an increasing trend and Elon is likely to tweet more on Sunday, Monday and Thursday when compared to the other days of the week. Information here is interesting, however, how we can use it. To find it out, we can use two values, the weekdays and the expected values. So let me explain how we can use them and come up with an algorithm. First, I assign weight percentages for each one. So 70% for the expected values and 30% for the days. Then I come up with a weight scale for each metric. For example, let's look at the figure 1 and match it with my scale. In my scale, I set 4 different ranges. Each range represents the possibility of a tweet. So in the figure, as you can see, if our chart is below the 2, it means very low chance of tweets. So in our scale, we give it 10 points to that. If it is between 2 and 3, the day has little possibility of a tweet, so we give it 30 points. If our line is between 3 and 4, it has higher possibility, so we give it 50. And finally, if it is higher than 4, we assume that we got the highest chance of a tweet, so we give it full 70 points. Now, let's look at our second chart and do the same thing with the weekdays. Since it weighs 30%, we assign Monday 30 points, Sunday 20 points, and Thursday 10 points. The rest will be 0 because they have a lower possibility. At that point, all we had to do is sum both of them up and come up with a total score. And if that score is lesser than 33, then we can say that we don't expect any tweets from Elon. If it is between 33 and 66, then we can say that maybe we can get a tweet. And finally, if it is higher than 66 points, then we can expect a tweet from Elon on the given day. In the code, I've implemented it in the calculate group function. However, I won't be going over that because it's not that interesting. Now we can move on to the final piece of code. And all it does is to apply our function to each element and export our predictions as a JSON file. And inside the JSON file, we got many objects with ds and y-hat variables. The ds variable contains the date in epoch time, and the y-hat variable determines the prediction on the date described by the ds. If it is 0, low possibility of a tweet. If it's 1, mediocre chance of tweet, and if it is 2, we expect higher possibility of a tweet. But why did I do that? Well, it is pretty simple. I want to import the date to its website to display it visually. Sure, reading the date is fun, but come on, this is all about memes, so of course I have to make a simple website. Anyway, now let's look at the website logic and see how it works. So, as for the tech stack goes, I keep it very simple. I've used Express.js as our backend, EJS for templating, and finally the Bootstrap for some styling. And yes, I haven't used any front-end frameworks, which is considered a sin nowadays. Anyway, if you look at our backend, as you can see, it is super simple. All we have is the home route, which renders our main page, and the predict date route, which passes the prediction info, then renders the page again. As for our front end, it is again quite simple. It contains few headings, a form that lets users pick a date and get a prediction, a dial to show the prediction, and finally some styling and behavior checks. But enough talking, now let's see it in action. So I open up my browser and go to the site I've deployed. And yes, I know, I've deployed it on Heroku and I don't care about scaling, and no, it doesn't have any domain, because I'm already hoarding enough domains anyways. So once the website is opened, we are greeted with this amazing design, which is absolutely gorgeous. But I digress. Now let's pick a date. Let's choose 8th of March, and as you can see, it indicated us March tweet, which says that Elon would highly likely to tweet on that date. So let's choose another one. For example, the 17th of March. Now we are unsure and only hope for some tweets. And finally, let's pick the 27th of March. And as you can see, at that date we don't expect any tweets from Elon. So much sad. In the end, I've really enjoyed making this project, and I will be putting its link in the description down below, so you can play it around with it as well. but keep in mind that it might not always be up and running. So I will also put its GitHub link in the description as well. Oh, and also a classical warning, don't take any of it as an investment advice, it is made just for fun. Also, I know I haven't uploaded in a while, however projects like these do take time and I hope you guys have enjoyed it. If so, it would be great if you hit the like button. And finally, if you have any suggestions, questions, project or tutorial ideas, I would love to hear them in the comments down below. So see you next time, take care.